Assalamualaikum, students and friends. Today's episode is a sequel to a previous upload on molarity. This time we focus on the equivalent concentration of a solution, also known as normality. Just like molarity, normality also refers to the number of moles of a solute in a given liter of the solution. But how does normality differ from molarity? You'll find out if you hang on till the end of this video. So just relax, watch and learn. Question number 1. What is the normality of letter a 2.5 molar sulfuric acid solution? Letter B, a solution containing 60 grams of sodium hydroxide in 1.0 liter of solution. And letter C, a solution that is made by dissolving 12 grams of magnesium hydroxide in enough water to make 1.0 liter of solution. Question number 2. A sample of 50.0 ml of a 0.240 normal solution of potassium hydroxide is titrated with a 0.650 normal solution of phosphoric acid. Question is, how many ml of the acid are needed to reach the endpoint? Is it letter A, 10.2 ml? Is it letter B, 18.5 ml? Is it letter C, 25 ml? Or is it letter D, 50 ml? First thing first, what is normality? Normality is the number of mole equivalents per liter of a solution. And to calculate for normality, we just divide the number of equivalents by the volume of the solution expressed in liters. The number of equivalents is equal to the mass of the solute expressed in grams divided by its equivalent weight. And equivalent weight is simply the molar mass of the solute divided by a number expressed as small letter n, which is the number of equivalents or the magnitude of the net ionic charge of the hydrogen ion, that is, if the solute is an acid, and the net ionic charge of the negative hydroxide ion if the solute is a base. All right. So our first example is if the solute is a hydroiodic acid whose formula is capital H, capital I. All right. So this solute, capital HI or hydroiodic acid, has the number small letter n equal to 1. All right. Because as given in this formula, there is only one positive hydrogen ion. All right. While uh, sulfuric acid, whose formula is H sub 2, SO sub 4, okay, This acid, sulfuric acid, has its small letter n value equal to 2 because, as you notice, there are two, all right? There are two hydrogen positive ions, right? And for our second example, supposing the solute is sodium hydroxide, NaOH, all right? So this solute has an n value equal to 1 because, as shown, there is only one hydroxide ion, all right, which is negative 1. But n only refers to the magnitude of the net ionic charge, all right? So we just disregard the negative sign of the charge of hydroxide, all right? While in the case of calcium hydroxide, whose formula is Ca quantity OH quantity sub 2, this compound has the n or small letter n value equal to 2 because, as shown, all right, in the formula, there are two hydroxide negative ion. And so therefore, its n value is equal to. For you to be able to understand better, let us proceed answering the questions. In question number 1, letter A, what is the normality of a 2.5 molar sulfuric acid solution? All right? So, when we say 2.5 molar, that can also be expressed as 2.5 moles per liter. All right? So, we can determine the mass in terms of grams. That is, 2.5 moles is simply multiplied by the molar mass of sulfuric acid, which is 98 grams per mole, right? So we will get the mass in grams of uh, sulfuric acid equal to 245 grams, right? The equivalent weight of the solute is just equal to the molar mass, which is 98 grams per mole, divided by the value, small letter n. And in the case of sulfuric acid, this small letter n is equal to 2 because there are two positive hydrogen ions as shown in this formula. All right? So 98 divided by 2, of course, that is equal to 49 grams per mole. All right? We call this the equivalent weight. Strictly speaking, the word weight is just a misnomer. This is actually more appropriately called the equivalent mass of sulfuric acid. All right? You notice it is related to the molar mass of the solute. All right? It's just that we have to consider the what we call the number of or the net value of the ionic charge. And in the case of an acid, all right, we look at the net charge of the hydrogen ion, which is equal to 2, right? And just like molar mass, this equivalent mass or weight is also expressed in grams per mole. So we emphasize why we have the value 2, right? Because there are two positive hydrogen ions. So its net charge is, of course, positive 1 times 2. So that gives us the small letter n equal to 2. All right, so after getting the equivalent weight or equivalent mass of the solute, we will now determine the number of equivalents, which is simply dividing the given mass in grams of the solute, which is 245 grams, all right, divided by the computed equivalent mass or weight, 49 grams per mole, and that gives us the number of equivalents equal to 5.0 mole. And so therefore, we are now ready to calculate for the normality, all right, of the given solution, whose formula is just dividing the number of equivalents by the given volume of the solution expressed in liters. That is, all right, the number of equivalents, which is 5.0 mole, divided by the volume specified in the question. The volume of the solution is 1 liter. That's why our final answer for the normality of the solution is 5.0 mole per liter, also expressed as 5.0 normal. Moving on now to question number 1, letter B. What is the normality of a solution containing 60 grams of sodium hydroxide in 1.0 liter of solution? So we proceed by getting the equivalent weight of the solute, all right? And that is just equal to 40 divided by 1, all right? Because 40 is the predetermined molar mass of sodium hydroxide, all right? And 1 here is the net ionic charge of hydroxide, all right? So the equivalent weight, which is expressed in grams per mole, is 40 grams per mole. And then we now determine the number equivalents, all right? Which is just the amount of mass in grams of sodium hydroxide, that is 60 grams, divided by the equivalent weight, all right, which is 40 grams per mole. And that gives us 1.5 moles as the number of equivalents. All right, so we can now calculate for the normality of this solution. It is simply the number of equivalents, that is 1.5 moles, all right, divided by or per liter of the solution, because the volume of the solution as specified is 1.0 liter. But our final answer is expressed, of course, in normal. So the normality equals 1.5 normals. For our question number 1, letter C, all right, what is the normality of a solution that is made by dissolving 12 grams of magnesium hydroxide in enough water to make 1.0 liter of the solution? All right, so we determine the equivalent weight or equivalent mass of magnesium hydroxide, all right, simply by dividing the molar mass, which is predetermined to be equal to 58 grams per mole, and the net ionic charge of hydroxide, all right, is 2 or positive 2. So that gives us the equivalent weight of the solute equal to 29 grams per mole. We can now therefore continue determining the number of equivalents, which is just the amount of solute expressed in grams, which is 12 grams. All right, so divide that by the equivalent weight or equivalent mass, 29 grams per mole, we will get the number of equivalents equal to 0.41 mole, that is. Hence, the normality, all right, is also equal to 0.41 mole per liter, because the volume of the solution as specified in the problem is also 1.0 liter. All right, our final answer therefore is that the normality is equal to 0.41 normals. And lastly, we now answer question number 2. All right, where we are given 50.0 ml of a 0.240 normal potassium hydroxide, all right, solution, which is titrated with a 0.650 normal solution of phosphoric acid. So this formula, H3PO4, is the formula for phosphoric acid. So this is a question involving the neutralization reaction of phosphoric acid and potassium hydroxide. All right? Potassium hydroxide is a base, while phosphoric acid, of course, is an acid. And we can apply here the neutralization equation. All right? So the equation simply says that the product of the volume of the acid and the given normality of the acid solution, all right, B sub A times N sub A, is just equal to the product of the volume of the base, B sub B, and the normality of the base solution, all right? And since what we are going to calculate is the volume of the acid, phosphoric acid, so that is B sub A, we just isolated, and this is the working formula for finding the volume of the acid required, all right, for the two what we call solutions to be neutralized. So substituting the normality of the base, which is 0.240 normals, okay, times the volume of the base solution, which is 50.0 milliliters, and divided by the normality of the acid solution, which is 0.650 normals. So doing our math, we will arrive at the value for the volume of the acid, phosphoric acid, equal to 18.5 milliliters. Finally, answering question number 2, all right? So the best answer, correct answer, is in fact option letter B, where the volume of the acid, phosphoric acid, required for neutralization is equal to 18.5 milliliters. So that's it. We're done. Till the next episode. Mabuhay. Alhamdulillah, mashallah. Thank you very much for watching. Please follow me in my FB page, and please don't forget to subscribe to my YouTube channel.